Good evening, my dear students. In this session, I'll be discussing about carbon and its compounds. How to represent the carbon? Can you tell me? C. That's good. So, this carbon based chemistry is a huge branch of chemistry and it's called organic chemistry. Various natural materials have been improved because of this wonderful growth in organic chemistry. Several natural and synthetic materials have been prepared based on different types of reaction and mechanisms in organic chemistry. In fact, in health sector, we can see a tremendous improvement, particularly with regard to the food preservatives and the drugs. And that is why chemistry has a very important role in humans' daily life. In fact, more and more valuable materials are coming and they provide us better comforts. For example, you cannot miss chemistry even in the early morning when you get up from the bed. You are using toothbrush and where you can find nylon is an essential material and that is nothing but a chemical polymer. And from toothbrush to parachute, this chemical is extensively used. And after all, it is an organic compound. And when you consider contact lens, you may wonder it is a polymer. When I say it is a polymer, it is an acrylic resin, you would have thought that it is some other material, but this is nothing but a chemical and basically the organic compound, organic polymer made out of acrylic compounds, acrylic monomers, and they are called acrylic resins. So the contact lens. And you are very familiarized with this non-stick cookware, and that is basically an organic compound. Similarly, you have got polyurethane soles for shoes, and we have wonderful and colorful paints on metals and civil structures. Then we have got a lot of food preservatives also based on organic chemistry. And you are very familiar with these adhesive tapes. In fact, these polyurethane soles, color paints, food preservatives, adhesive tapes, all are carbon-based compounds only. In future, when you go for higher studies, you will be studying organic chemistry as a separate paper. It is a separate branch of study. It is something like an ocean. There are many organic chemicals that are useful in making up hair, skin, and fingernail beautification, etc. You take nail polish, it is basically an organic substance. So a wide variety of substances such as drugs, vitamins, plastics, let it be natural or synthetic. When you say natural, that is biopolymers or biocompounds or biomolecules like carbohydrate, proteins, fats, etc. So these are all organic molecules only. A wide variety of substances such as drugs, vitamins, plastics, natural and synthetic fibers. Of course, as you know very well about these carbohydrates, all are essentially organic compounds only. Now let us talk about this speciality of carbon. What is the unique nature of carbon? You can call it the, for example, it is versatility. It's this versatility that popularizes this carbon element. Versatility means that is adaptation. Like that is, it has multiple uses and it will adapt itself in such a way that it can be effectively utilized in many places. And basically, these carbon based compounds have many covalent bond. You should know something about covalent bond. There are, when I say bond, let me take a chalk piece like this. So, are you able to see the chalk piece? So, when I break this, it's broken. Since it is physically bound, this is broken physically. But can you imagine whether I can break the bond between sodium and the chlorine? You cannot do that just by physical means. It means that is, you have to necessarily break the chemical bond by using some chemical force only. So you should understand there are two types of bond: physical bond, chemical bond. As in the case of chalk piece, in the chalk piece, it has got various elements like calcium, carbon, oxygen. Among themselves, you have got a lot of chemical bonds. And as molecules, they develop in turn a bond, several bond among themselves. And the interactive forces, that is the bond between the molecules, are called physical bond, or you can simply call intermolecular force of attraction. And that can also be represented as van der Waals force. So it's a physical force of attraction only, and that is why when you break it, you are actually breaking the physical force of attraction only. For example, I have got the chalk piece, I can crush into powder. What I have done, I have not broken the bond, chemical bond. I have broken only the physical bond, that is the intermolecular force of attraction. Do you agree with me? So now let me talk about chemical bond. So the chemical bond, see, for example, we are familiar with various types of chemical reaction. What do you mean by chemical reaction? Cleavage of old bond and formation of a new bond, is it not? So that, for example, let me consider sodium and chlorine. When the sodium and chlorine, or otherwise you can take sodium hydroxide, NaOH. Similarly, you have got a bond between hydrochloric acid, that is hydrogen, chlorine, hydrogen and chlorine, there is a bond. So there is a breakage of these bonds and formation of a new bond to form a compound like sodium chloride and water. Similarly, when you discuss about the chemical bond, you know very well by cleaving, by breaking the chemical bond, it is able to establish various chemical properties. For example, a compound can be oxidized, can be hydrolyzed, can be reacting with water, can be reacting with alcohol. Likewise, there are plenty of acid, bases, etc. Therefore, these organic compounds, which are basically formed out of carbon and hydrogen. So such type of compounds which are based on carbon and hydrogen are called hydrocarbon. Do you agree with me? And don't think that in organic chemistry, in organic compound, you have got only carbon and hydrogen. Besides, you have oxygen, halogen. What do you mean by halogen? Halo means salt. Gen means to generate. So the salt forming groups are called halogens. Likewise, now when we talk about the chemical properties of carbon compounds, you should know something about the combustion. Means what? Burning in presence of air, burning the compound in presence of air. That is called combustion. There are oxidation, then addition reaction, substitution reaction. Likewise, you have got various types. And we will be discussing in this chapter about the covalent nature of the covalent bond in carbon and the versatility, that is versatile nature of carbon, and we'll be discussing about the saturated hydrocarbons and the unsaturated hydrocarbons. Then various compounds like chains, branches, it has got various structures, rings. Then I will be discussing about what is functional group, what is homologous series. Then I will be explaining about how to name the organic compound by a definite system called IUPAC nomenclature system, IUPAC nomenclature system. And after discussing these chemical properties, these are all the major things. Then for any compound, we have to discuss the preparation, physical properties, chemical properties, then applications, that is uses. And we should know something about the structures also. Now let us take up the covalent bond in carbon. So, like James Bond, when I say James Bond, you will immediately say that is 007, 007. Likewise, a C bond, you can remember like this. And this C bond where the covalent bond is present in carbon. For example, let me consider hydrogen here. You have got one hydrogen and another hydrogen. It is given here. Now, hydrogen has got one electron, another hydrogen, another electron. Now, when they come together, now there will be some common overlap because these electrons are revolving around the hydrogen nucleus, and in another hydrogen atom, another electron, its own electron is revolving around the nucleus. But when they are coming together, there is a chance of overlapping of orbital. So when I say chemical bond, two electrons are needed, but in book they would have shown as a dot, another dot representing electron, and by connecting this you will form a bond. But it is not like that. Okay, you cannot straight away take it like this. This is something like a common passage between the two atoms. Assuming that I have got this room and I have got another hall there. In between that I have got a passage. Okay, when I open the door, I can travel there and that person can come here. Likewise, there will be an interaction between these two rooms. Likewise, you have got this hydrogen. I hope now you should be able to understand. So, this electron can travel here and this electron can travel here. Thereby, something like a flat system, there will be some common usage, common path, common open terrace. Everybody is enjoying the common facilities available in that apartment. Okay. Likewise, it is a kind of overlapping of orbital. Orbital is nothing but the three-dimensional space available around the nucleus. Okay, right. Now, let us see what is the valency, covalency. First of all, you should know something about valency. What is valency? It is the binding tendency. It is the combining capacity of an element or an atom. For example, when I say hydrogen, it has got one binding tendency. When I say chlorine, it has got one binding tendency. So when I join these two, hydrogen and chlorine, 1:1, so they can form HCl. For example, let me take calcium. Calcium has got two binding tendency. They will be having two hook-like arrangements so that it can interact with two monovalent atoms, like in the case of chlorine. And that is why calcium with the double hook and chlorine with the single hook means it can form one hook, one bond like this, and another bond will come here. Okay, so another chlorine will form here. Thereby you are able to get calcium chloride, CaCl2. So in this case, when I talk about covalency, it is the equal combining power of participating atoms. And therefore, as I already mentioned, valency is nothing but the combining capacity of an atom. It is the number of electrons available in the outermost orbit for bonding. For example, let me say we have got carbon here, first orbit, second orbit, third orbit, likewise. So, the electrons which are available in the outermost shell, for bonding, they are called valencies. They decide the valency. Do you understand? Right. Let us go deeper, further. For instance, for example, what is covalent bond? When you are asked this directly question, you can also directly answer. It is a mutual sharing of electron. Please make a note of it. What is covalent bond? It is formed by the mutual sharing of electrons. Mutual sharing means what? This chlorine will say, I will give one electron. This chlorine will say, I will give this electron. So that we will have some common combining tendency. So that we can enjoy mutually. Sharing mutually. Do you understand this point? So this is called covalency. For example, as I already shown here, these two hydrogen atoms are kept afar. There is no interaction between them. But when they are brought together, nearby, what happens? There is a tendency to form a common overlapping, and that is why you are able to get a groundnut-like shell. Are you able to see this? So it forms a bond. Actually, it is a total interaction between the electron cloud available in the exterior orbit. Do you understand? And similarly, Cl, they combine so that they form Cl-Cl bond. And similarly, you've got methane. So methane is essentially consisting 4 hydrogen atom and 1 carbon atom. So let us consider this cube, this room like a cube. This is a cubical one. Assuming that at the center of the room you have got carbon. So on one end, that is, you have got hydrogen, and on another hydrogen, another hydrogen, another hydrogen, another hydrogen, like a tripod of a camera. Okay. So on a tripod of a camera, I have fixed, instead of camera, okay, I have fixed this carbon, and the legs are, that is, bonded by the hydrogen. Do you understand? And I have fixed another hydrogen there. Now that is called the tetrahedral structure of methane. Do you understand? And what is the formula of methane? Meth means 1 carbon atom. So ane means it is a hydrocarbon, and which is grouped under alkane. Therefore, it forms methane. Do you understand this? Okay. So methane means CH4. Okay. Now, if there is any question, you can ask me. Any question? Any doubt? Have you noted down all these points?
Different physical bonds.
Physical bond and chemical bond. Physical bond, please note down, physical bond, it is an interaction between the two molecules. Whereas chemical bond is, it is an interaction between the two atoms. Do you agree with me? For example, several molecules combine together to form a compound, and there are definite ratio of atoms they combine to form a molecule. Let me consider. I have got a water. See, this is the flask where I have got full water, hot water. This water is nothing but H2O. Okay. So this flask contains water molecules. How much? This is around 1.5 liters. So 1.5 liters of molecules are there. That is, they occupy this space. Okay, being liquid, it is spreading everywhere like this. If it is a solid, it will be rigid, is it not? It will not be moving here and there, but they will be vibrating. But being liquid, it will be moving here and there. The rate of diffusion is better than the solid. But in the case of gas, assuming that I have got some gas cylinder where I have put water vapor, what will happen? This water vapor will be moving here and there. That is, these water molecules will be moving here and there. Now, for the states of matter, for example, in the case of water, when it is in gaseous phase, we call it steam. In liquid state, we call water. In frozen stage, that is solid state, we call it ice. Now, which makes the difference between these three compounds, types of compounds, all are same compound only, water, but physically they are different. It is because of the result of the physical properties, is it not? So what happened that here, in case of that is water vapor, the rate of diffusion is more. It means the cohesive force, the van der Waals force, or the intermolecular force of attraction in gas is the least, and that is why the rate of diffusion is more. So the water vapor will be moving here and there. But in the case of liquid, it is somewhat tightly bound, so there is a restricted movement. But in the case of solid, it is rigidly bound, tightly bound, and that is why it is available as a solid ice. So do you understand? So physical bonds and their breakages, they result in physical properties. And what are those physical properties? When I break that is a solid into liquid, how can I break? Either I can crush or by heating, is it not? So when I heat, what happens? Melting. So solid to liquid is melting. It can also be called fusion. And liquid to gas, evaporation. When it is called evaporation, when it is called vaporization, when the liquid is becoming vapor in its natural state or at room temperature or isothermally reversibly, what happens at a constant temperature, it is called vapor. For example, just you can spill some amount of water on the floor, and when you switch on the fan, it gets dried up. Do you want to say it has reached the boiling point so that it can become a gas? No. That is what the other one is, boiling. Are you able to follow? So boiling is different from evaporation. So these are all physical properties only. Do you understand? But chemical bond. So chemical properties are resulted because of the cleavage of chemical bonding, and that is why the chemical bonds are very important. In fact, chemical bonds are stronger than physical bond. For instance, you can crush sodium chloride into powder. It means you have made the compound into a powder, and you can further melt it also or dissolve it also. But when it is chemically involved, then only you are breaking the bond between sodium and the chlorine. For example, when it is when the sodium chloride solution is subjected into electricity, when we pass electric current, what happens? Electrolysis takes place. The electrolytic bond present in the sodium chloride electrolyte is cleaved, that is broken, so that they become sodium cation and the chloride anion. Do you understand this? So this is the concept behind this. Okay. So I hope now you should be able to find out the difference between the physical bond and chemical bond. So physical bond results in physical properties like melting, boiling, solubility, viscosity. All these are all physical properties. But what about chemical properties? They involve in some reagents. So it involves in some chemical bond cleavage, and that is why they result in chemical properties. Okay. Kavya, Purida. Taufik, Purida po.
Yes, sir.
Okay. Okay. Sudiksha.
Yes, sir.
Okay. ஏதாவது டவுட் வந்துன்னா கேட்கலாம்.
The notes, the images last நடத்துவா சார்?
அதுதான் நம்மளோட e-learning இதில் வந்துடும், வெப்சைட்டில் வந்துடும். Okay, right. Let us move to the next one. I hope now you should be able to understand what do you mean by methane, and how to represent this by structures, and how to coin the name. So we will be discussing one by one. Okay, right. Now you look at this. Side by side you can take down the notes also. You should develop the practice of taking down notes when you watch the teacher's video or teacher's lectures. Okay, right. Now we have got two carbon atoms. The specialty of carbon here is the covalency, as I already told you. Okay, and not only that, this carbon has the tendency to form the chain, and that is why it's called catenation. Take down. Catenation means chain forming tendency. So likewise, it can build up as a chain. Now initially we had one carbon and four hydrogen. One carbon, four hydrogen means its valency is 4. The valency of carbon is 4. So it should have definitely 4 bonds around that. In the case of methane, you had one carbon, you can see here, one carbon and 4 hydrogen. Got it? So you must ensure that each carbon should have 4 valencies, that is 4 bonds. Now let us put C and C. And now you have to account for 4 bonding. So you can put 1 bond, 2 bond, 3 bonds, and next bond, 4th bond, 5th bond, 6th bond. So fill up with the hydrogen and there will be a CC bond. Are you able to follow? There are actually 2 types of bond. I want to explain this one. One is called a sigma bond. Sigma bond will be developed because of linear overlapping of orbital like this. So these orbitals will be, so you look at my hands, they linearly overlap like this. Okay, so there will be a grip. So it is stronger. So sigma bond is stronger. So what is called a sigma bond? It is because of linear overlapping of orbital. Do you understand? Right. And there is another type of orbital overlapping, that is called sidewise overlapping. Okay, so when they combine sidewise, for example, it is something like a balloon, another balloon, it combines like this. So when they combine like this, it is a sidewise overlapping. It is also called lateral overlapping, where the points of attachment may be many, but the extent of overlapping is less. Do you understand this statement? For example, when you hold these 2 hands, you can go to the maximum extent and it is tightly held. Is it not? But when I combine like this, beyond certain limit, I cannot combine this. Okay? But there are lot of points of attachment. Unfortunately, the extent of overlapping is less. I cannot hold like this. Okay? So in that case, this is called pi bond. Are you able to follow? It is something like a pi. You know pi. How to write down the pi? You know the letter pi. That is the, what is the value of pi in mathematics? Anyone?
22 by 7.
22 by 7 or 3.14 cc. So this pi, so it looks like a pi, and that's why it's called pi bond. Do you understand? This is sigma bond. Okay, so sigma bond is stronger, pi bond is weaker, because pi bond is sideways. It can sideways link like this, and it can link like this. Okay, it can link like this. Are you able to follow? Right. Then let us talk about this ethane. Eth means 2 carbon atoms. So this is CH3. For example, let us combine these 2, carbon carbon. It is a single bond. Okay, so carbon carbon single bond. It is a sigma bond. And this carbon can combine with a hydrogen also. So it has combined. This is the perspective view, 3D view, and this is the planar view. Okay, so in that case, I think this is for better visualization. We have put like this. Okay, so that we can study the carbon-carbon rotation, carbon-carbon bond rotation. All these things can be studied. Whereas here it is a simple carbon-carbon bond, like that is there is one carbon-carbon bond, and how many CH bonds are there? 1, 2, 3, 4, 5, 6. So you should be able to count 6 CH bonds and 1 CC bond in ethane. Do you understand? Now let us talk about double covalent bond, where it is called ethene. You have got carbon, you have got another carbon. Now one is sigma bond, another is pi bond. So it is combined together as a double bond. So how many bonds are there? There are 2 double bond, 2 bonds in a double bond. One bond is sigma, take down. One bond is sigma, another bond is pi. So together they are called carbon-carbon double bond. Do you understand? Now, can you count the type of bonds available? Anyone? What are the bonds available? Tell me.
Six.
No.
Sigma bond, plus bond.
How many carbon sigma bond? You have to identify like this. Please note down. How many carbon sigma bonds are there? So carbon sigma bond, carbon pi bond, carbon hydrogen sigma bond. Now tell me the count. You can easily study. See this, how many CH, all are single bond, sigma bond. So there are 4 CH sigma bond. Got it? And there is 1 carbon sigma bond. And there is 1 carbon pi bond. You got this point? Right. Now let us go to the nitrogen, where you have got triple bond. Nitrogen, it involves 3 bonds. So if it is a triple bond, then what is the nature? That is, there will be 1 sigma overlapping, sigma bond, and there will be a vertical overlapping, that is pi bond, another horizontal overlapping like this. Okay, so there are 3 types of overlapping. So one is sigma bond, and there are 2 pi bonds like this, like this. So this is the case of ethane. Do you understand? So CH triple bond CH. In the case of methyl cyanide, there is a triple bond between carbon and the nitrogen. So as I already mentioned, in triple bond, how many pi bonds are there? Anyone? Tell me.
2 pi.
1 sigma bond, 2 pi bonds. Do you understand? 1 sigma bond, 2 pi bonds. Are you able to follow? Now can you count in the case of CH3C triple bond N? Please note down. Now can you type and send? I got here, that is, let me ask you, this is CH2 double bond CH2, CH triple bond, okay? I can put triple bond CH, right? Now try CH triple bond CH. What are the bonds available? Please type and tell me. That is CC, C single bond C, how much? And then C pi bond, how much? And this one is CC sigma bond. So how many bonds? And CH sigma bond. So type the answer and send it me. Come on, quick. Look at this. Nine question ketunda. That is, we have CH triple bond CH. So you have got 1 sigma bond and 2 pi bond, and this is 1 sigma bond, 1 sigma bond. So CH sigma bond, how much? 2. And CC sigma bond, how much? 1. And that is CC pi bond is equal to 1. Okay, right. So this is called ethane. This is known as ethane. So we have got methane. I was explaining about methane. What is the structure of molecular formula of methane? CH4. What is ethane? So structure of ethane is C2H. How much? Tell me. Huh? H6.
C2H6.
Okay. So what is the formula of ethene? C2H4. What is the formula of ethine? That is C2H2. So it means you just go through these structures and their names. They end with the suffix that is ane, whereas this is ene, this is yne. So anes, they are the suffixes of alkane. Are you able to follow? Note down, alkane. Ene, they can be called alkenes. Yne means alkynes. Take down. They have the general formula CnH2n plus 2. Whereas alkenes, they have the general formula that is CnH2n. And alkynes have CnH2n minus 2. I note it down. Let us consider alkanes. Before that, you should know when I say meth represents one carbon, C1. When I say eth, these are all prefixes, C2. Prop, C3. Bute, C4. Pent, C5. Hex, C6. Hept or sept, C7. Oct, C8. Non, C9. Dec, that's called, that is C10. Okay. Now let us consider, at least you should know up to C6. Meth and alkanes, they have the general formula CnH2n plus 2. Now meth plus ane, what is that? Methane. What is the general formula? That is C, it has got only one carbon atom, so 2 into 1 plus 2, that is 4. Eth, and its alkane, ethane. So C2, 2 2s are 4, 4 plus 2, 6. So C2H6. Got it? Similarly, propane. So C3, what is that? 3 2s are 6 plus 2, 8. Now can you tell me butane? Tell me. C4. Come out.
C4H6.
That's all. C4H10. What about pentane?
C5H12.
C5H12. Got it? Right. Now let us consider these alkanes particularly. We will try to write down the structures also. Let me consider methane. So here I have only one carbon. So I need to provide 4 valency. So fill up with the 4 hydrogen. H, H, H. Then you can call it methane. That is CH4. Got it? Similarly for ethane. Okay, eth means 2 carbon atoms. So let me write first 2 carbon atom with a bond. Okay, so I have got a bond here. Now I can organize the valencies like this. Now insert hydrogen, 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 hydrogen. So it means C2H4. It's 6. Can you write down similarly propane? Okay, can you tell me how to write down? We must write 4 carbon atoms. Yogesh, can you tell me here how many hydrogen atom I should insert?
3 carbon atoms.
3 hydrogen atom. Here 2 hydrogen atom. Here 3 hydrogen atom. Why? In each carbon atom I should have the valency 4, is it not? So valency 1, valency 2, valency 3, valency 4. So I should have 4 valencies. Okay. So in such a way I am writing the CH bond, CC bond, etc. Clear? Therefore I can put H here, here, here. So this is the way you have to write down the structural formula. Are you able to understand this? And now you count C3, H 3 plus 3, 6 plus 2, 8, C3H8. Can anyone tell me for butane? Tell me. Get me the steps. First, what am I supposed to do?
4 carbon atoms.
4 carbon atoms. 1, 2, 3, 4. Then put hydrogen. In the terminal you have got 3. And here only 2. And again in the terminal 3. So it can be written as H, H, H. So that can be represented as CH3. And this can be represented as CH2. And this can also be represented as CH2. And this is represented as CH3. Now you can put CH3 simply. So this structure can be represented like this also. Butane. Okay. So can you get me pentane and hexane like this? So what you are supposed to do, write down the name. Okay. That is pentane and its structure and its molecular formula. So write down for pentane and hexane. Please send it.